Good day, everyone. This is the first recorded lecture for CPE 208 or Engineering Economy. So, this discussion is all about the Module 1, the Introduction to the Principles of Engineering Economics. So, it includes the definitions, the principles, design process, cost concepts, present economic studies. Okay, so the duration of this module is 3 weeks. Okay, for introduction, engineers are considered as the problem solvers of many organizations, right? So, although they come in different specializations, they all likely to use their knowledge to discover new methods of doing things more economically. Okay, so for your case, you are an computer engineering student, okay, and I am an industrial engineering or an industrial engineering professional. Okay, but we are the same, okay? We engineers always seek improvement, okay? Uh, the only difference is our specialization, okay? So, uh, the study of economics or the engineering economics is very important for us. Okay, so engineering solutions are not bounded but with limitless applications. That's why we have with different engineering specializations. So it has limitless applications in the aspect of business opportunity. So since every problem may have multiple solutions, knowing how to rationally choose the design with optimal economic result is very important. Okay, because a problem may have so many solutions, but we engineers don't easily select a solution. We are going to digest the very best, okay, the very best or better solution, okay. So knowing how to rationally choose them by studying economic aspect of them, okay. So this can be learned through engineering economics, which deals with evaluation of the economic aspect of design solutions, okay. So since we are engineers, our work are designing, okay, designing solutions for the industry we chose, okay. So one would argue that economic aspects are just for financial professionals. Yes, so, somebody of you may argue or may complain that he doesn't need any of the economic aspect because there is the financial professionals or uh, the accountants, okay, that who can handle financial and economic value. But that is not true, okay, because we engineers are also inclined with that, okay. So this is because an engineering project in reality should not only be physically feasible, okay. Our project should not only be physically feasible but also economically affordable, okay, because if our project is not economically affordable, no one will buy it, okay, and then it will not be successful. Okay, so in other words, beyond the aspect of function and performance, which we engineers are more inclined to, solutions must be achieved economically. Okay, so this is because of scarce resources such as time, material, manpower, money, and many other more are affected by decisions on a design. Okay, because since we have limited resources, we cannot afford to waste them on a solution that is not the best. Okay, so if not profitable, an excellent solution can fall to a certain debt, and that is true. Okay, so every solution shall be economically sound and profitable. Okay, so let's go to the objectives. After careful study of this module, you should be able to do the following. Define terminologies under the principle of engineering economics. 2. Understand and explain the principle of engineering economics. 3. Integrate the principle of engineering economics to the design process. 4. Learn the concepts of cost and apply them in decision making. And be familiar with present uh, business situation or the present economic uh, situations. Okay, so it is not written here. It is a typographical error. Okay, so For your pre-test in a separate paper, write the things you already know about the topic. But before that, I want you to watch this video so that you have a uh, prior knowledge to the topic we are going to discuss. Okay.
Subscribe to my YouTube channel and click on this bell icon to get all the latest videos. Hello guys, welcome to my channel. It's been a long time since I make a video. Suppose you are a CSE engineer or computer science engineer or you are electronic engineer. Suppose this kind of thing, people, especially the students of engineering, don't want to learn economics or the other side subjects of computer science or electronic subject. So today I'll show you the benefits of learning economics with your engineering subject. So our topic is top reasons to learn economics as an engineer or an engineering subject. Suppose you make a product and you don't know how to produce it more and more and how to make it perfectly and how to demand and how to supply it properly to the user and how to market this product or your particular device that you designed to engineer it. And today I will talk about the combination of economics and an engineering perspective so that you get a clear idea what is economics basically is and how it can help you to market your product or hardware or software and how to use it properly and efficiently and how to handle supply demand and how to satisfy the people most. So let's jump into the video. So economics talks about scarcity, trade-off, efficiency, and the best solution possible in your limited resources. So I will talk about all of these four components, which are really the core part of economics. You need to really understand it properly to connect it with the engineering. Okay. So let's start with the scarcity. So as you know that we have unlimited want. Different kind of people have different kind of taste and different kind of want. So the want is unlimited, but we have very limited resources. And we need to use those limited resources efficiently. Listen guys, this is really important. We need to use all our resources, our limited resources efficiently to gain an efficient success or efficient way so that we can meet our demand properly in a limited resource. So economics teaches us about the scarcity and how we can solve this scarcity. It also teaches us this. So our ultimate solution we get from scarcity, and the next thing is trade-off. So trade-off means sacrifice. We cannot have all the product same time because we have a very limited resources, limited money, limited, but we have unlimited want. So we cannot have all the product at the same time. We must have to sacrifice some other product to get one product. So our next topic is efficiency, which economics handle this really perfectly. And economics is maximizing our performance at the lowest price possible. So as you can see, the maximum efficiency, and the maximum efficiency is also it in case of speed, or suppose you want a high speed and you want it very low cost. Okay, so then you need to consider the efficiency level, or suppose you want a very high quality device but at efficient price rate that is within your limit and it will help you to work properly, and but it is efficient, it is under your limitation. You can buy those product within your limit and you can get the maximum performance at the lowest price possible. So the cost should be in downward and the quality speed should be concerned most at lowest cost. Okay, so this is the main purpose of efficiency, which economics teaches you really perfectly. The next thing, we have the best solution. As we have already talked about, the economics gives us the best solution possible in our limited resources. Suppose we have this PC, laptop, and this smartphone, and all of them priced at suppose 1000 US dollar. All of them, those PC, laptop, and those smartphone, all are in similar price. Now, what you wanted to buy and why? Suppose you need a very good quality PC. You need to edit a lot of videos and you play a lot of high-end quality games. and you will make a lots of apps development, Android apps development, or any 3D graphics work and intensive work, you probably buy a desktop. Or suppose you prefer laptop, if you use the portable things a lot and you travel a lot, you will select those laptop are really good for portability. And you can also select smartphone if you want. So it is up to you which is really best for you. So economics teaches in your limitation of price and product what you should buy. Okay, it teaches you that what should you buy and what will make you satisfied, and this is the best solution for you. You need to buy one because you have limited resources, $1,000, but you cannot buy three of them at once because you have only $1,000, so you cannot buy three of them. Only one is your concern, and the economics help you to choose which one is the best for you. Our next topic is demand. Economics talks about demand, supply, satisfaction, and quantity. I'll talk about it in a brief. So suppose demand, and suppose you made a product or a software or a hardware, or you designed a hardware or software which is really good for the people. It is really helpful, efficient, and people are really feeling good using your product, or the product you have made is a revolutionary product that people are buying this in a huge demand, and your product is in huge demand, and lots of people are taking it from you, or you are selling this at high. But the problem is your product demand is so high that you cannot produce enough, and it makes your supply less. So as you can see in the picture, if you have high demand, people are taking your product in high, and you are selling it within huge margin, and people are using it and feeling really well, but your supply is taking down because lots of people are taking it, but you cannot provide enough supply to them. This is a really big problem. When your demand is high, your supply is low, there is an inverse relationship between demand and supply. So if you cannot provide enough supply to the people, okay, so you will not get enough profit. So you need to build a more bigger laboratory, more bigger resources, and gather more human resources to build more supply, and you need to make your laboratory more better, or everything you need to upgrade to produce and supply those kind of product more and more, so that people get enough supply, and as the demand and supply should be balanced. Okay, so economics showed you how you can increase the supply of your product, and how to meet people's demand and their satisfaction, what people want. And here in the picture, as you can see, I have drawn a graph for you guys, which is a graph between demand and supply, because and also a price and quantity is also concerned. Suppose the product price is suppose the product you have made, or the hardware or the software you designed, is really high price, so people are not buying it because it is really high price. Okay, but you can supply more because there is demand, there is less demand, there is high supply. Okay, there is an inverse relationship. So people are not buying it, but you have enough supply. So that is not good for you because people are not buying it. You want people to buy your product, and if you want to increase the demand, you need to decrease the price. As you can see in the curve, it is inverse relationship. If you increase the demand, the price goes down. If you decrease the demand, the price goes up. So you need to understand all those relationship between the demand, price, and supply. And as you can see in the right side, if your supply is high, your demand goes down, and your demand goes high, supply goes down. And if your supply is high, price is high. So there is an equal relationship between price and supply, because if your price is high, so people are not buying the product as much, so the demand is low, but the supply is high because you have a lot of product in your stock. But in demand, as you can see, the demand is low because the price is so high. So you need to understand and balance your supply and demand, and economics teach you how to balance your supply and demand and make it equilibrium. Okay, so our next topic is, for an engineer, Suppose you need to think about hardware, the particular hardware that you created or designed. You need to think about the software, you need to think about the marketing, and you need to understand how to meet the supply and how you can market those software to people so that people buy it, and they buy it so that you get much more profit from it. And you need to meet the proper supply for this product or your software so that you get much more profit. Or the next part is meet the demand of the people. And you should also concern in mind that the quantity should be enough. Okay, the quantity should be enough, so you need to build larger laboratory to produce more quantity of your product. And you know should know also the hardware part, the software part, and you need to know the marketing of this product. You need to know this how to supply this product properly. You need to know how to meet the demand of the people. So all of these are really important for an engineer to learn how to market the software, how to meet people's need, and how to supply it. And all those mechanisms engineers and economics came together to understand. Suppose you are making the product and also publishing the product, and you don't know how to publish it or how to meet people's need or demand, then you are not a proper engineer. Suppose you are an engineer who designed the software and it is really useful for the people and people are wanting this and they get advantages and they are efficiently using the software, and which is really good for them and really revolutionary software, and you are producing enough product to meet your supply and demand. So all those things are really connected, and all those things are the core part of economics, and particularly really important for an engineer. So I recommend you to learn engineering and economics at the.
So after watching that video, I hope that you get some uh, some knowledge about our topic for today for this module. Okay, so for your pretest in a separate paper, write the things you already know about the topic. You can also add your expectations about this module. Rate your knowledge from 1 to 5. 5 is the highest about each lesson stated in the objective, so it is 1 to 5. Okay, so lesson proper. Introduction to Engineering Economy. 1.0 Definitions. Engineering is the profession in which knowledge of mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically, economically the materials and forces of nature for the benefit of mankind. So that is the definition of engineering. So as engineers, we should uh, be well versed in all aspects of our profession. Okay, not only with the technical ones, but of course with other aspects. Okay, that is mentioned in its definition. Next, 1.2 Engineering Economy. So it involves the systematic evaluation of the economic merits of proposed solution to engineering problems. So the, in engineering economy, we're not just proposing solution. Okay, we are studying it in a systematic manner. Okay, so to be economically acceptable, example affordable, solutions to engineering problems must demonstrate a positive balance of long-term benefits over long-term cost. Okay, so our solutions, the solutions that we are going to make in the future should have a balance of it. Okay, so long-term benefits as well as the cost, because there are so many costs while using a solution. Okay, so and they must also 1.2.1 promote the well-being and survival of an organization, because we are not uh, making solutions for the present time only. Okay, we are making solutions for the long term, okay, long run of the organization we are serving. Okay, so next 1.2.2 embody creative and innovative technology and ideas. So we have to be updated, okay, be updated with the present technology, okay? And we should also be creative uh, in creating ideas. Okay, so 1.2.3 permit identification and scrutiny of their estimated outcomes. So this means that we should discern or to break down into elements what are the components of an outcome, okay, so that we can estimate it. Okay, so scrutiny means critical observation. Okay, so you need here your critical thinking. Okay, so next, 1.2.4, translate profitability to the bottom line through a valid and acceptable measure of merit. So we should uh, put the concept of profitability as our uh, paramount objective, okay, in making solutions. And of course, we should have a strong basis, okay? We should have a valid basis, which is an acceptable measure, okay? So 1.3, some applications of engineering economy. First, choosing the best design for high efficiency gas furnace. Okay, so that's one application, because in engineering economy, you will learn to balance the the design, the application, and the cost. Okay, so if your solution runs economically, okay, then it shall be efficient. Okay, just like in the example, the gas furnace. Do you see? Have you ever see a gas furnace? So gas furnace utilize what? Resources, okay, such as gas, okay, and manpower. So if the design of the system or the gas furnace itself is economic viable, then it should be efficient. Next, 1.3.2, selecting the most suitable robot for a welding operation on an automotive assembly line. So nowadays, robotics is very famous in the manufacturing industry. Okay, so here in the example, it is said that robots are used in the welding operation of an automotive assembly line. If you ever watch videos about modern automotive manufacturing companies like Toyota, Honda, Ford, etc., you can notice uh, their manufacturing lines using robots. Okay, so next, making a recommendation about whether jet airplanes for an overnight delivery service should be purchased or leased. Okay, if you belong to an industry wherein you are buying jet airplanes, okay, for transportation purposes. So you know uh, what is more economically to do, if purchasing or just leasing, okay, or renting. Leasing means renting. So next, determining the optimal staffing plan for a computer help desk. So here it applies to the human resources. Okay, so this applies to the work system. If you design a work system, okay, it should make the working condition efficiently. Okay, so 1.4, engineering economic analysis focuses on cost, revenues, and benefits. So those are the focus of our analysis here that occur at different times. So the time is a factor also. So the economic analysis of cost, benefits, and revenues occurring over time. Okay, because time is as good as money. Okay, because time is gold. It has a worth. Okay, so stop wasting your time for unworthy activities. Okay, so we will also consider time in engineering economics. So next, 2.0, the principles of engineering economics. Engineering economics is the set of principles. So it is not just a principle, but there are set involving to the principles. Okay, so that provide a comprehensive doctrine for developing the methodology. So comprehensive. So this will encompasses this will encompass broad aspects, okay, of economics. So once a problem or need has been clearly defined, the foundation of the discipline can be discussed in terms of 7 principles. So we have to clearly define first what is the problem before we apply these 7 principles. First, develop the alternatives. So carefully define the problem, then the choice or decision is among alternatives. Okay, so different problems, different alternatives. Okay, the alternatives need to be identified and then defined for subsequent analysis. So we should not only identify problems, but we should explain it. Okay, so that we can uh, analyze it more uh, accurately. Okay, more accurately. So next, 2.2, focus on the differences. Only the differences in expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decision because we are after the outcomes here. Okay, so the differences in outcomes, we will weigh every outcomes of the alternatives. Okay, so next, use a consistent viewpoint. So the prospective outcomes of the alternatives, economic and other, should be consistently developed from a defined viewpoint or perspective. So we should not be changing our viewpoints here. So we should root our viewpoints, okay, or the basis to the principles of engineering economy, and we should be consistent. Okay, so 2.4, use a common unit of measure. Using a common unit of measure to enumerate as many of the prospective outcomes as possible will simply the analysis of the alternatives. So we should, as long as possible, we should be using common measure here for all of the uh, quantities that we are measuring to have uniformity and avoid confusion. Okay, so next, consider all relevant criteria. Selection of a preferred alternative or decision making requires the use of criterion or several criteria. The decision process should consider both the outcomes enumerated in the monetary unit and those expressed in some other unit of measurement or made explicitly in a descriptive manner. Okay, so we should develop a criteria here. Okay, and we should not only focus on the uh, monetarial, okay, monetarial criteria or the criteria that is only based on money, but also on the other aspects. Okay, because there are some aspects that are not based on money. Okay, just like the time value. Okay, uh, other values like distance, okay, and many more. So next, make risk and uncertainty explicit, okay. So risk and uncertainty are inherent in estimating the future outcomes of the alternatives and should be recognized in their analysis and comparison. So since risk and uncertain outcomes are are inevitable, okay, so it comes naturally, we should make clear of them, okay. We should uh, define them, identify them ahead of time, okay. So next, 2.7, revisit your decisions. Improve this decision-making results from an adaptive process to the extent practicable. Okay? The initial projected outcomes of the selected alternative should be subsequently compared with actual results achieved. So we are not just making a one-time decision here. We are on the process of continuous improvement. If your decision fails a certain aspect, you should uh, you should you should make some developments in your decision and able to cater for those aspects that are not uh, accommodated by the previous decision. Okay, so we are in a continuous improvement here. So we should always check or revisit our decisions that we have made. Okay. 3.0 Engineering Economy and the Design Process. An engineering economy study is accomplished using a structured procedure and mathematical modeling techniques. Okay, so we will not only uh, study some sort of procedure here, but it is structured. So we are going to follow some uh, concrete rules here. Okay, the economic results are then used in a decision situation that normally includes other engineering knowledge and input. Okay, so table 1-1, the general relationship between the engineering economic analysis, okay, procedure and the engineering design process. So this table shows the relationship of the engineering economic analysis procedure to the engineering design process. Okay, so step 1 under the engineering economic is problem recognition, definition, and evaluation. Okay, so step 2, development of the feasible alternatives. Okay, so the step 1 belongs to the activity 1 of engineering design process, which is problem or need definition. Okay, next number 2, it belongs to problem or need formulation and evaluation and synthesis of possible solutions. Okay, the alternatives is present there. Okay, so number 3 to 5, okay, number 3 to 5, development of the outcomes and cash flows for each alternative. Okay, this is now the estimating of the expenses. Next, selection of criterion or criteria. Okay, then 5, analysis and comparison of the alternatives. So after um, getting all the expenses and the criteria, we will now analyze in step 5. Now 3 to 5 step belongs to step activity number 4 of engineering design process, which is analysis, optimization, and evaluation. Okay, so number 6 under engineering economy is selection of preferred alternative. It belongs to number 5 activity of engineering design. So it is a specification of preferred alternative. Then lastly, 7 performance monitoring and post-evaluation results. It belongs to step 6 communication of engineering design process. Okay, so that is the relationship. Next, 3.1, problem definition. The first step of engineering economic analysis procedure or the problem definition is particularly important. Why? Because since it provides the basis for the rest of the analysis. Okay, so we are just basing our analysis from the problem. Okay, we should not go beyond the scope of the problem. Okay, otherwise we will commit mistakes. Okay, so a problem must be well understood and stated in an explicit form or clear way, okay, before the project team proceeds with the rest of the analysis. So if we are in a team, we should not move to the part of analysis if the problem is not properly defined, okay, because we may encounter error in our analysis or not relevant decisions or analysis. Okay. Next, 3.1.1, the term problem is used here generically. So it, uh, it also uh, it also applies to uh, simple problems. Okay. So it includes all decision situations for which an engineering economy analysis is required. Okay, so almost all decision situations. So recognition of the problem is normally stimulated by internal or external organization needs or requirements. Okay, so this problem may be from the internal organization that we are serving or from the outside organization. Okay, an operating problem within a company or the internal need. Uh, so operating problem belongs to internal, okay? Or a customer expectation about a product or service, so it is external because customers are from outside of the organization. Those are the examples. Next, 3.1.2. Once the problem is recognized, its formulation should be viewed from a systems perspective. What is a systems perspective? So, uh, part by part here, we are going to analyze. So that is the boundary or extent of the situation needs to be carefully defined. Okay, thus establishing the elements of the problem and what constitute its environment. So by studying the elements of the problem, okay, but uh, through dealing it with a system perspective, okay, we can carefully define, okay, uh, the needs, okay, the needs of the situation. So 3.2, development of alternatives. So the two primary actions in step 2 of the procedure are: number one, searching for potential alternatives. So it includes under development of alternative searching. Then, second, screening them. After you search the alternatives, you have to screen them, okay? And to select a smaller group of feasible alternatives. So we will trim down, okay? Trim down the number of alternatives in to a group of more accurate ones, okay? Or more relevant ones for detailed analysis. Okay, so the term feasible here means that each alternative selected for further analysis is judged. So when we say feasible, it is a result of the judgment of the based on criterions. Okay, based on preliminary evaluation to meet or exceed the requirements established for the situation. So they should meet the requirements. Okay. So 3.2.1, searching for superior alternatives. Creativity and resourcefulness were emphasized as being absolutely essential to the development of potential alternatives. So our creative side here should be functioning, because the more ideas that come up to our mind, okay, the more ways that we propose, the closer we are to the best alternative. Okay, so the difference between good alternative and great alternatives depends largely on the individuals or groups problem solving efficiency. Okay, such efficiency can be increased in the following ways. So if you have that ability to be a creative solver, okay, uh, let your teammates know it. Okay, don't be shy. Okay, perform your task as a member of a team, because in a real-time situation, okay, when you go to the industry, you will meet people and professionals that you will work with, uh, you will work with in a team. Okay, so you should be cooperative. So 3.2.1, so these are the ways that we can increase our efficiency. So concentrate on redefining one problem at a time. So we should concentrate at the problem one at a time, so that we can focus on that problem. Okay, next, develop many redefinitions for the problem. So we should not uh, be contented with one definition of a problem, because as I said earlier, we should be uh, creative here. We should see all the perspectives surrounding the problem. Okay, so we may define it in other ways. Okay, next, avoid making judgments as new problem definitions are created. So don't be judgmental, okay? So just welcome the other definitions of problem, because we never know that it is the most accurate one, okay? Until we uh, evaluate it. So next, attempt to redefine a problem in terms that are dramatically different from the original step 1 problem definition. Okay, so it includes creativity again, and thinking outside the box. Okay, so next, make sure that the true problem is well researched and understood. So we should not deviate from the main problem, okay? Although we are encouraged to be creative, okay? So it should be aligned with the main problem. Next, developing investment alternatives. Okay, engineers are at the very heart of creating value for a firm. So, by turning innovative and creative ideas into new and re-engineered commercial products and services. So that is the job that the company is counting on us. Okay? We are at the heart of creating value. So we engineers are always after the value, okay? Value of services, value of product. Okay, so we don't want waste. Okay, we only want value. So most of these ideas require investment of money, and only a few of all feasible ideas can be developed due to lack of time, knowledge, and resources. So we are going to work. Okay, we are going to work and spend our time. Of course, the company will pay for us, and not all the feasible ideas will be entertained. Only those that are more effective. Okay. Next, classical brainstorming is the most well-known and often used technique for idea generation. It is based on the fundamental principles of deferment of judgment and that quantity breeds quality. So there are 4 rules for successful brainstorming. So brainstorming is about making new ideas, okay, or generating ideas. First, criticism is ruled out. So you should avoid criticism. You should be welcoming. Okay, freewheeling is welcome. So freewheeling means that those ideas that are out of the scope are welcome. Okay, so we never know that they can be included. Okay, so they are welcome. So quantity is wanted. So we want more ideas, and combination and improvements are sought. So with that more ideas, we can combine and improve. Okay, so next basic classical brainstorming steps. First is preparation. The participants are selected. So the members of a team will be selected and a preliminary statement of the problem is circulated. Okay, so brainstorming, a warm-up session with simple unrelated problems is conducted. So the relevant problem and the 4 rules of brainstorming are presented. Okay, the rules that we have read in uh, above. Okay, and ideas are generated and recorded using checklists. So we should record whatever we are producing or generating in a brainstorming. So next, evaluation. The ideas are evaluated relative to the problem. Okay, so always when we are evaluating, we should always base our evaluation to the problem. Okay, so generally a brainstorming group should consist of 4 to 7 people, although some suggest larger groups. So those are the minimum members. So next, nominal group technique, NGT. So what is this? This is developed by Andre P. Delbecq and Andrew H. Van de Ven. It involves a structured group. So it is a structured group, meaning it is not randomly selected, but it is formed by purposely. Okay, so meeting designed to incorporate individual ideas and judgments into a group consensus. Okay, so maybe a team is composed of different professionals major in different fields. Okay, by correctly applying the NGT, it is possible for groups of people, preferably 5 to 10, to generate investment alternatives or other ideas for improving the competitiveness of the firm. Okay, indeed, the technique can be used to obtain group thinking or consensus on a wide range of topics. Okay, the more brains, the better. Okay, so for example, a question that might be given to the group is, what are the most important problems or opportunities for improvements of? So that is a good question to start brainstorming. So the basic format of an NGT session is as follows. So first, an individual silent generation of ideas. So each each member will be uh, writing or speaking out all the ideas they have in mind. Next, individual round robin feedback and recording of ideas. Of course, you will let your team member to have a feedback with regards to your ideas. Okay, so group clarification of each idea. So we should consult each of one to clarify if the idea is really good. Okay. So next, individual voting and ranking to prioritize ideas. So of course, in a brainstorming we can generate more ideas, but we have to classify them with accordance to their importance through ranking. Okay, so discussion of group consensus results at the end. Of course, as a summary. Okay, so Example 1-1, defining the problem and developing alternatives. So the management team of a small furniture manufacturing company is under pressure to increase profitability, to get a much needed loan from the bank to purchase a more modern pattern cutting machine. So management team is going to propose in purchasing a machine, okay, that will serve the small furniture manufacturing company. So one proposed solution is to sell waste wood chips, okay, and shavings to a local charcoal manufacturer instead of using them to fuel space heaters for the company's office and areas. Okay, so those are the two alternatives. Okay, so letter A, define the company's problem. Next, formulate the problem in a variety of creative ways. Letter B, develop at least a potential alternative for your reformulated problems in part A. Don't concern yourself with feasibility at this point because here we are just creating ideas, okay, and defining the problem. So solution for letter A. The company's problem appears to be that revenues are not sufficiently covering costs. Okay, so it appears that the profit that the company is gaining is not uh, offsetting the cost. Okay, so several reformulations can be posed here. So number one, reformulation is the problem is to increase revenues while reducing costs, of course. So the problem is to maintain revenues while reducing costs. Okay, if we cannot increase the cost and if we cannot increase the revenue, sorry, while reducing the cost, we can maintain the revenue, okay? At least maintaining it, not lowering it, okay? And reducing the cost. Then number three, the problem is an accounting system that provides distorted cost information. Okay, as you notice, they are hierarchical. So number one is the best. Okay, if they can do that to the company, then it will be the best. So number three is about proposing an accounting system. Okay, so it is more useful, okay, in analyzing the distorted cost information or those costs that are not recognized. Okay, so the problem is that the new machine is really not needed and hence there is no need for a bank loan. So lastly, number four with the less importance because it ranks number four, uh, the decision is the machine is not needed, okay, because uh, it will be a cost for the company because they are uh, making a loan to the bank. Okay, so letter B, based only on for reformulation one, so it based on the first because it is the highest in hierarchy. Okay, an alternative is to sell wood chips and saving as long as increased revenue exceeds extra expenses. So that's it by selling wood chips because when they use the machine, it will produce a byproduct of wood chips, okay, that they can sell, and the profit from gaining from selling it will add to the revenue of the company, okay, that will offset expenses that may be required to hit the buildings. Okay, so another alternative is to discontinue the manufacture of specialty items and concentrate on standardized high volume products. So that's another, because when they concentrate on uh, standardized product, they can easily produce it. And when they can easily produce it, they can uh, produce more quantity. Okay, so yet another alternative is to pool purchasing, accounting, engineering, and other white collar support services with other small firms. So this last alternative is to outsource. Okay, do you know outsourcing? So the outsourcing means that a company will not hire directly. Okay, will not hire directly those positions being or those jobs that uh, being said here, purchasing, accounting, engineering, they can hire from other companies because there are purchasing company, accounting company, engineering company. There are a specialty organization. Okay, it will reduce the cost. Okay, in the area by contracting with the local company involved in providing these services. Okay, it will definitely reduce the cost. So that's the example, okay, of defining the problem and making alternatives. Now let's go to 3.3, development of prospective outcomes. So step 3 of the engineering economic analysis procedure incorporates principles 2, 3, and 4 from section 1.2. So these principles is incorporated here and uses the basic cash flow approach employed in engineering economy. So a cash flow occurs when money is transferred from one organization or individual to another. Okay, that is why it is called as cash flow. Okay, the movement of money from one entity to another. So thus, a cash flow represents the economic effects of an alternative in terms of money spent and received. So it is a representation of some effects, okay, economic effects. So, in addition to the economic aspect of decision making, non-monetary factors or attributes often play a significant role in the final recommendation. Example of objectives other than profit maximization or cost minimization that can be important to an organization include the following. So, these are the other aspects. So meeting or exceeding customer expectations. Of course, satisfying the customer will give value, okay, value to the company. So safety to employees and to the public. So a safety working environment will minimize or eradicate accidents, okay, because accidents in the workplace is a cost for the company. Because if a worker is injured, the company will have to spend money for his or her medications. Okay, so next, improving employee satisfaction. Yes, it also adds value. Why? Because a satisfied employee, okay, a satisfied employee works best, okay, or works better. So it can be more efficient. Next, maintaining production flexibility to meet changing demands. Okay, so the production should be flexible enough to adapt to changes because in a real-time environment, real-time working environment, some changes, uh, some changes over time occur. For example, a new order, a new order has come from the customers. The company cannot ignore that. Okay, so a change may be done in the plans. Okay, so the production flexibility should be maintained. So next, meeting or exceeding all environmental requirements. Okay, so the permits, okay, the government permits about the environmental requirements falls here, okay, because if a company doesn't adhere to the laws and regulations and environmental uh, policies of a government, they will be charged or at worst be closed. Okay, so it should adhere to the all environmental requirements. Next, achieving good public relations or being an exemplary member of the community. That's a value, of course, because being a good model of quality of product, for example, to a community will give a company a big yes or a high value in the eyes of the customers. Thus, the customers will be buying uh, buying products from that company. So, good public relations and exemplary member of the community is another way to achieve value. Next, 3.4, selection of a decision criterion. So the selection of a decision criterion, step 4 of the analysis procedure, so it is included in this step 4, remember? So incorporates principle 5, consider all relevant criteria. The decision maker will normally select the alternative that will be best serve the long-term interest of the owners of the organization because most commonly when it comes to objectives of a company, our bosses in the company want long-term, okay, long-term satisfaction of the needs of the company. So it is also true that the economic decision criterion should reflect on a consistent and proper viewpoint, which is included in the principle 3. You can go back to the principles of engineering economy to be maintained throughout an engineering economy study. Okay, so next 3.5, analysis and comparison of alternatives. Analysis of the economic aspect of an engineering problem in step 5 is largely based on cash flow estimates for the feasible alternatives selected for detailed study. Yes, it is just estimates of cash flow. Why? Because they are just alternatives. Okay? They are just alternatives that are considered as feasible. So there are no actual computations of cash flows, just estimates. Okay, so a substantial effort is normally required to obtain reasonable accurate forecast of cash flows. So our forecast or estimate should be uh, close to accurate. Okay, and other factor in view of, for example, inflationary or deflationary, we should also consider that uh, if the peso versus dollars is high or low, we should also consider that. Okay, so the exchange rate movements, so regulatory legal mandates that often occur because uh, we should align our alternatives with them, because when we uh, violate a law in our uh, government, we can be charged of violating the law. So that is a cost. Clearly, the consideration of future uncertainties, which is included in the Principle 6, is an essential part of engineering economy study. When cash flow and other required estimates are eventually determined, alternatives can be compared based on their differences, as called for by the Principle 2. Okay? So next, selection of the preferred alternative. So when the first 5 steps of the engineering economics analysis procedure have been done properly, the preferred alternative, which is in step 6, is simply a result of the total effort. So it is the uh, the aggregate, okay, aggregate result of all the effort. So thus, the soundness of the technical economic modeling and analysis technique dictates the quality of the results obtained and recommended course of action. So the result will be basing on the quality, quality and techniques that are used in the analysis, modeling and analysis. So in step 6, this is included in step 5 of the engineering design process. Specification of the preferred alternative. So in the engineering design process, we have to enumerate the specifications of the preferred alternative for us to go on with the plan. Okay? So when done as part of the design effort. Next, 3.7. Performance monitoring and post-evaluation of results. The final step implements Principle 7 and is accomplished during and after the time that the results achieved from the selected alternative are collected. Okay, so we have to, because Principle 7 is about monitoring, okay, the result. We have to monitor the milestone that our our chosen alternative has achieved, okay, if it if it will benefit the company in the long run or not. So we have to monitor it. Okay, so monitoring project performance during this operational phase improves the achievements of related goals and objectives. Okay, so a checklist will do. Okay, we can use a checklist in monitoring these goals and objectives and reduces the variability in desired results, because when we are not monitoring the result, variability or deviating from the uh, objectives and goals set up by planning will eventually occur. Okay, so in step 7 is also the follow-up step to a previous analysis, comparing actual result achieved with the previously estimated outcomes. So you will notice here that uh, outcome to outcome evaluation. Okay, we will not stop here until we got the best outcome. Okay, we will not stop evaluating. Okay, the aim is to learn how to do better analysis, and the feedback from post-implementation evaluation is important to continuing improvement. Of course, the historical data that we have gathered, okay, or the historical results that our previous steps have produced, we should use it in our uh, proceeding steps. Okay, so next, the aim is to learn how to do better analysis. Okay, it's done, and unfortunately, like step one, this final step is often not done consistently. Of course, uh, as I observed in the real working environment, when I work as a supervisor in a manufacturing company, I observed this scenario that uh, more often than not, the implementators of a project fail to monitor the results or the effects of the project. So therefore, it needs particular attention to ensure feedback for use in ongoing and subsequent studies. So feedbacks is very important also. Okay, because through feedbacks, uh, we can acknowledge the effects and or the impacts of the alternatives or the outcome that we have chosen, okay, to the stakeholders. So example 1-2, application of the engineering economic analysis procedure. So a friend of yours bought a small apartment building for $100,000. So this setup is in the US of A. Okay, so it is dollars. In a college town, she spent $10,000 of her own money for the building and obtained a mortgage from a local bank for remaining $90,000. So what is a mortgage? A mortgage is it is a legal uh, agreement between the borrower and the bank. Okay, if the borrower fails to pay the amount monthly or any period according uh, to their uh, to their contract, then the bank can get any property that the borrower owns. Okay, that is a mortgage. Okay, so the annual mortgage payment to the bank is $10,500. So annually is the payment. My friend also expects that annual maintenance on the building and grounds will be $15,000. There are four apartments, two bedrooms each in the building that can each be rented for $360 per month. So there are many factors, not only uh, the direct expenditures, but also the indirect, which is the other expenses like the maintenance, okay, and the other, okay. So refer to the 7-step procedure in table 1-1, left hand side to answer these questions, okay. So letter A, does your friend have a problem? If so, what is it? So where is the table 1-1? So let's go back to the top. Okay, so here it is. So here it is, the table 1-1. You can uh, revisit it, okay, for your answer. So letter A, does your friend have a problem? If so, what is it? Letter B, what are her alternatives? Identify at least three. So let's answer those one by one. So letter A, the answer is a quick set of calculations shows that your friend does indeed have a problem. So what is it? So a lot more money is being spent by your friend each year. Okay? So your friend is spending a lot of money. So $10,500 plus $15,000 is equal to $25,500. Then is being received. Okay? Because he only received 4 times $360 times 12. Okay? It's equal to $17,280. So why is the computation like this? Because it is said here in the problem, there are 4 apartments. That's why 4 times. Okay? And $360 is the cost of the rent for that apartment. And then 12 is for the 12 months of a year. Okay? So, your friend is spending more than what he is receiving. Okay? The problem could be that the monthly rent is too low. Okay? She's losing the difference. So get the difference of $25,500 and $17,280. So the difference is 8,220 per year. Okay. Now that's a problem. Okay. Next. Letter B. What are her alternatives? Identify at least three. So here are the alternatives. Option 1. Raise the rent. Okay. Will the market bear an increase? Okay. So he can raise the rent. First, but first he should consult the authorities on the who have the regulation on uh, for apartment business. Okay. Maybe the uh, the municipal government, okay, or he can consult the uh, renters, okay, if they can afford the increase. Now option 2, lower maintenance expenses, okay, but not so far as to cause safety problems. So he can lower down the maintenance expenses, but he uh, should not put into danger, okay, the uh, the safety of the ones who are living there. Okay, so he can cut down a bit. For example, he should not he should not repaint. Okay, repainting uh, the walls. Okay, because it will do. But repairing major cracks on the walls or repairing holes in the roof are a must. Okay, so next option 3, sell the apartment building. Okay, so he can sell the apartment building, but what about the loss? Okay, is he will uh, get back his money of investment? So option 4, abandon the building, bad for your friend's reputation. So it will be a bad. It is a bad reputation for her his for your friend. Okay, that's why it is placed on option 4. So this is hierarchy. Okay, guys, meaning option 1 uh, is the best among all because it is placed in number 1 position. Okay, so option 1, raise total monthly rent to $1,440 plus dollars are for the 4 apartments to cover monthly expenses. Okay, of $2,125. So you can raise the the rent, okay, with the plus dollar, okay, for other expenses. Note that the minimum increase, so the minimum increase in rent would be the difference, okay, the difference of 2,125 and 1,440 divided by 4 because we have to divide, okay, we have to divide that to all apartments. Yes, it is per apartment. He will raise $171.25 per apartment. Okay, per month, almost a 50% increase. Okay, that will do. So option 2, lower monthly expenses. Okay, from $2,125, he should subtract uh, an amount, okay, of cost so that these expenses are covered by monthly revenue. Okay, so that those expenses will be offset by the revenue. So this would have to be accomplished primarily by lowering the maintenance cost. There's not much to be done about the annual mortgage cost unless a favorable financing opportunity presents itself. So monthly maintenance expenses would have to be reduced. Okay, so how many? So the difference again. Okay, the difference of 1,440 and 10,500 divided by 12. It is negative, but we will make it positive because we're just getting the difference. So $565. This represents more than 50% decrease in maintenance expense. So this is good. Next, option 3. Try to sell the apartment building for an amount of dollar which recovers the original $10,000 investment and ideally recovers the 685 per month loss because it is from the 8,220 divided by 12 on the venture during the time it was owned. Okay, so option 4, walk away from the venture and kiss your investment goodbye. The bank would likely assume possession through foreclose and may try to collect fees from your friend. This option would also be very bad for your friend's credit rating, so option 4 is not advisable. Okay, so letter D. What is the question for letter D? Let's go back. So select a criterion for discriminating among alternatives and use it to advise your friend on which course of action to pursue. So the answer is one criterion could be to minimize the expected loss of money. So that's one criterion. In this case, you might advise your friend to pursue option 1 or 3 because they are about uh, minimizing the expected loss of money. Next, letter E. Attempt to analyze and compare the alternatives in view of at least one criterion in addition to cost. Okay, so letter E. For example, let's use credit worthiness, okay, as an additional criterion. So option 4 is immediately ruled out. Why? Because it's not about credit worthiness, but it is about losing credentials as a borrower of the bank. Okay, so exercising option 3 could also harm your friend's credit rating because he might sell the apartment for a lower cost than what he have expend. Okay, so thus option 1 and 2 may be her only realistic and acceptable alternatives. Okay, so we just trim down the alternatives into 2. Okay, next, letter F. What should your friend do based on the information you and she have generated? So your friend should probably do a market analysis of comparable housing in the area to see if the rent could be raised. So he can interview fellow business owners of apartments. Okay, maybe a fresh coat of paint and a new carpeting would make an apartment more appealing to prospective renters. Okay, so improving the physical appearance of the apartment. If so, the rent can probably be raised, okay? By improving the physical characteristic of the apartment, the rent can be raised, okay? And it is uh, your friend can convince the prospective renters, okay? While keeping 100% occupancy of the 4 apartments. Next example, example 1-3. Get rid of old clunker. So what is a clunker? So it is an old machine. Okay, engineering economy is all about deciding among competing alternatives or competing alternatives. When the time value of money is not a key ingredient in the problem, so chapter 2 should be referenced. So what is chapter 2? Chapter 2 is the next topic of this module, which is about cost concepts. Okay? So if the time value of money is integral to an engineering problem that we can find in chapter 4, okay? So you will know that provides an explanation of how to analyze these problems. So consider the situation. Linda and Jerry are faced with a car replacement opportunity where an interest rate can be ignored. So Jerry's old clunker that averaged 10 miles per gallon mpg of gasoline can be traded in toward a vehicle that gets 15 mpg. So he can trade it with the other one. Or as an alternative, Linda's 25 mpg car can be traded in toward a new hybrid vehicle that averages 50 mpg. So they can upgrade, okay? So if they drive both cars 12,000 miles per year and their goal is to minimize annual gas consumption, which car should be replaced? Jerry's or Linda's? So they can only afford to upgrade one car at this time. So we have to use some computations here, okay, for the decision. So for the solution, Jerry's trade-in will save 12,000 miles per year, okay, over 10 mpg minus quantity 12,000 miles per year over 15 mpg is equal to 1,200 gallons per year minus 800 gallons per year equals 400 gallons per year. So Jerry's trade-in will save 400 gallons per year based on the computation. Okay, so the computation is just simple. Okay, first the 12,000 miles per year that that both the cars that they are driving uh, will uh, it will consume, okay, is just divided by the 10 miles per gallon of gasoline. Okay, then the other one, it is subtracted to the the quotient of 12,000 miles per year over 15, because 15 is the upgrade. Okay, we are getting only the difference. Okay, so the difference is 400 gallons per year. Now for Linda's trade-in, we'll save, so the same manner, we will just divide the 12,000 miles per year, because that is their goal to minimize annual gas consumption. Okay, we'll divide by the 25. Okay, then we will subtract it with the quotient of 12,000 miles per year and the upgrade, which is 50. Okay, so saving 480 gallons per year, so which is higher. Okay, so therefore Jerry should trade in his vehicle to save more gasoline. Okay, so Jerry should trade in because Linda's trade in will save more. That's why Jerry should uh, sell his vehicle than Linda. Okay. Next, 4.0, cost concepts for decision making. So this is another topic, okay, that we are referring to. Okay, so there are a variety of costs to be considered in an engineering economic analysis. So there are varieties. So expect different kinds of costs. So these costs differ in their frequency of occurrence, relative magnitude, and the degree of impact on the study. So we will differentiate each of these. Okay. So for the first category, we have the fixed, variable, and incremental costs. So what are these costs? So fixed costs are those unaffected by changes in activity level over a feasible range of operation for the capacity of capability available. So this cost will not be affected, okay, by such changes. So typical fixed costs include insurance and taxes on facilities, okay, so because the cost of them is only based on the company uh, who are issuing those insurance, okay, and based on the government, of course, when it comes to taxes. Then the general management and administrative salaries, license fees, and interest costs on borrowed capital. So those are fixed costs. Next is the variable cost, are those associated with an operation that varies in total with the quantity of output or other measures of activity level. So this is the opposite of fixed cost, because variable cost, from the word itself, it varies, okay, depending on the quantity of output. Okay, so for example, the cost of material and labor used in a product or service are variable cost. Why? Because uh, the higher supply of materials, the cheaper it will be. So the cost will be low. So it can vary, okay? And the labor used, if the system designed by engineers in a working environment is efficient, then uh, lesser la less labor is required. So the cost will vary, okay? Because they vary in total with the number of output units, even though the cost per unit stay the same. Okay, so next, an incremental cost or incremental revenue is the additional cost or revenue that results from increasing the output of a system by one or more units. So this one is for situational. Okay, if there is a situation wherein the company uh, calls to increase, okay, increase the capability or the quality of a system or a product, incremental cost will be charged. Okay, so it is often associated with go no go decisions that involve a limited change in output or activity level, because this is a critical decision. Okay, that's why the managers should study this well before uh, applying this incremental cost. Next, example 2-1, fixed and variable cost. In connection with surfacing a new highway, a contractor has a choice of two sites on which to set up the asphalt mixing plant equipment. Okay, so the contractor estimates that it will cost $2.75 per cubic yard mile, okay, to haul uh, the asphalt paving material from the mixing plant to the job location. Factors relating to the two mixing sites are as follows. Production costs of each site are the same. So the fixed cost here is the production cost, while these other ones are the variable costs. So here are the cost factor. Average hauling distance. From site A, it's 4 miles. From site B, it's 3 miles. Monthly rental of site. Okay, $2,000, $7,000. Next, cost to set up and remove equipment. So $15,000 and $50,000. Hauling expense. So that's it. It is fixed. So flag person. Site A is not required and site B is required. Okay? So when you say flag person, he's the one leading, okay, the operation in such a way that they are giving signals, okay? Giving signals to the operators. So, next, the job requires 50,000 cubic yards of mixed asphalt paving material. It is estimated that 4 months, 17 weeks, so we convert into weeks, 17 weeks of 5 working days, okay, with 5 working days per week, will be required for the job. Compare the two sites in terms of their fixed, variable, and total cost. Assume that the cost of the return trip is negligible. Okay, so we will just compute for the one-way trip and not the return trip. So, which is the better site? For the selected site, how many cubic yards of paving material does the contractor have to deliver before starting to make a profit? If paid for $12,000 per cubic yard delivered to the job's location. So, we will decide on that. Then the solution is the fixed and the variable cost for this job are indicated in this table. Okay, so the site rental, setup, removable cost, and the cost of the flag person at site B would be constant for the total job. Okay, so those are the constant, but the hauling costs would vary in total amount with the distance because it is based on the distance, and thus with the total output quantity of cubic yards per miles. Okay, so here are the costs. The rent is fixed cost, setup removal fixed, flag person fixed because they are we are going to uh, we are going to outsource them. Okay, the decision is not in the company but to the owners of the businesses that the company is going to transact. Okay, so only hauling is the variable cost. Okay, so site A, the rent is 8,000. We will just add them. So setup removal 15,000. Flag first person is not needed to site A, so that's why it is 0. Then hauling, okay, 4 times 50,000. Why it is 4? Because it is stated that 4 miles, okay? 4 miles for average hauling distance. Multiply by 50,000. What is 50,000? It is the work requirement, the cubic yards. Then the per yard cost, which is $2.75. Okay? So you multiply all of them, then add all of this under side A. So the total is $573,000. So for site B, the rent is 28,000. The setup removal is 50,000. Then site B needs a flag person. So 5 5 times 5 times 17. Why 5? Because 5 days a week. Okay, so 17 weeks because it is 4 months, so 17 weeks. So multiply by the payment per day, which is $150. So the result is 12,750. Then for the howling, 3 because it requires 3 miles, and of course the 50,000 cubic yards, and the cost per yard, okay, cubic yards. So it is 412 412,500. So the total cost is $503,250. So therefore, site B, which has the larger fixed cost, okay, why does it has a larger fixed cost? Because if you add flag person, setup removal, and rent, it is larger than set A because site A doesn't need a flag person. Okay? Note that the extra fixed costs of site B are being traded off for reduced variable costs at the site. Okay, so the contractor will begin to make a profit at the point where total revenue equals the total cost of a function of the cubic yards as asphalt pavement mix delivered. So based on site B, we have 3 times. Why it is 3? Because it requires 3 miles. 3 miles times the uh, the cost per cubic yards, okay, is equal to $8.25 in variable cost per cubic yards delivered. So site B has a variable cost. So the total cost is equal to total revenue. Why? Because the total cost is like this. So 90,750. So this 90,750 is from the total fixed cost. If you add the rent, setup, removal, and flag person of site B, it is equal to 90,750. Then an addition of 8.25 dollars times X because it depends on it's a variable cost that change, okay, per yard delivered. Okay, is equal to $12 X. Why does it is $12? Because $12 is the profit. Okay, it is the profit paid per cubic yard delivered to the job location. That's why it has a variable X. Okay, so solving the equation, we have X is equal to 24,200 cubic yards delivered. So that is the X here. So therefore, by using site B, the contractor will begin to make a profit on the job after delivering 24,200 cubic yards of material. So that's it. We, uh, we know what is the amount of cubic yards of material that the work should accomplish before making a profit. Okay, so let's go to 4.2, direct, indirect, and standard cost. So 4.2.1, direct costs are costs that can be reasonably measured and allocated to a specific output or work activity. The labor and material costs directly associated with a product, service, or construction activity are direct costs. For example, the materials needed to make a pair of scissors would be a direct cost. So it is a direct cost if it is uh, a resources, okay, or a cost that is made from acquiring resources to make the product. Okay, so next, 4.2.2, indirect costs are costs that are difficult to allocate to a specific output or work activity. Normally, they are costs allocated through a selected formula, such as proportional to direct labor hours, direct labor dollars, or direct material dollars to outputs or work activities. For example, the cost of common tools, general supplies, and equipment maintenance in a plant are treated as indirect costs. This is because we have to uh, allocate this cost to every work that uh, this cost affects. Okay. 4.2.2.1 Overhead consists of plant operating costs that are not direct labor or indirect material cost. It is under indirect cost, the overhead cost. In this book, the terms indirect cost, overhead, and burden are used interchangeably. Okay, so indirect cost and overhead cost and burden are interchangeably used here. So examples of overhead included electricity, general repairs, property taxes, and supervision. Okay, so those are the overhead costs. Administrative and selling expenses are usually added to direct costs and overhead costs to arrive at a unit selling price for a product or service. So those are additional costs. Okay. Next, 4.2.3 standard costs are planned costs per unit of output that are established in advance of actual production or service delivery. So these are the costs that comes into plans. Okay, they are developed from anticipated direct labor hours, materials, and overhead categories with their established cost per unit. Because total overhead costs are associated with a certain level of production, this is an important condition that should be remembered when dealing with standard cost data. Standard cost plays an important role in cost control and other management functions. Okay, so this standard cost is also affected by the overhead costs. So these are the reminders for standard cost. So standard cost plays important role in estimating future manufacturing costs. So how? Because it is used uh, to estimate the cost of each uh, processing of an output. So next, measuring operating performance by comparing actual cost per unit with standard unit cost. Okay? Yes, because standard cost plays an important part here. Okay? To measure the performance. Because when the actual cost is higher with the standard cost, then it means that the performance is low. That the actual cost should be uh, the same, or at least the same with the standard unit cost, but it should not be higher. Okay, for the performance to be good. Okay, so next, preparing bids on products or services requested by customers. Since standard cost is used in estimating the uh, or anticipating the labor cost or direct labor cost and other resources, it can be used in preparing bids or the uh, preparing of portfolios to the buyers. Okay, because some of the buyers will ask for estimates of the products or services that the company is offering. Okay, next, establishing the value of work in process and finished inventories. Since standard cost uh, put some established cost per unit, then the completed work or and the work in process, as well as yes, the completed work that are in the inventory are what are to be established with value because of standard cost. Next, 4.3 cash cost versus book cost. A cost that involves payment of cash is called a cash cost and results in a cash flow. To distinguish it from one that does not involve a cash transaction and is reflected in accounting system as a non-cash cost. So they are just antonyms. Cash cost is an antonym of the non-cash cost. Okay, so this non-cash cost is often referred to as a book cost. So another term for non-cash cost is a book cost. So cash costs are estimated from the perspective established for analysis, which is in the principle number 3. Okay, and are the future expenses incurred for alternatives being analyzed. So cash cost plays an important role in analyzing those future expenses. So book costs are costs that do not involve cash payments, but rather represent the recovery of past expenditures over a fixed period of time. That is why it is also called as non-cash cost. So the most common example of book cost is the depreciation charge for the use of assets such as plant and equipment. Okay, because those equipments have their depreciation, those machines and equipments, because their value gets lower or depreciates over time. So in engineering economic analysis, only those costs that are cash flows or potential cash flows from the defined perspective for the analysis need to be considered. So depreciation, for example, is not a cash flow and is important in analysis only by it affects income taxes, which are cash flow. So depreciation is only used when we are talking about cost that affects taxes. Okay? 4.4. The sunk cost. A sunk cost is one that has occurred in the past and has no relevance to estimates of future costs and revenues related to an alternative course of action. Thus, a sunk cost is common to all alternatives. It's not part of the future prospective cash flows and can be disregarded in an engineering economic analysis. For instance, sunk costs are non-refundable cash outlays, such as earnest money on a house or money spent on a passport. That is why it is called sunk cost, because it represents an expenditure in the past. Okay, so it will not affect the estimates of or have no relevance for the future costs and revenues. So some costs are irretrievable, okay, consequences of past decisions, and therefore are irrelevant in the analysis and comparison of alternatives that affect the future. Even though it is sometimes emotionally difficult to do, some costs should be ignored. Okay, so except possibly to the extent that their existence assists you to participate better what will happen in the future. So there is an exemption. Okay, if the sunk cost gives you an idea of what will happen in the future, you should also consider it. So for the example 2-2, sunk cost in replacement analysis. So how do we use sunk cost in replacement analysis? So a classic example of sunk cost involves the replacement of assets. Okay, suppose that your firm is considering the replacement of a piece of equipment. It originally cost $50,000, is presently shown on the company records with a value of $20,000 and can be sold for an estimated $5,000. So imagine that you bought the equipment originally for $50,000. Okay, and in your records, its value is $20,000 based on the depreciation. But when you canvass or when you ask when you do your research, you can only sold it for 5,000. So there is a big difference uh, in the price, and that is the sunk cost. For for purposes of replacement analysis, the $50,000 is a sunk cost. Okay. However, one view is that the sunk cost should be considered as the difference between the value shown in the company records in the present realizable selling price. According to this viewpoint, the sunk cost is 20,000 minus 5,000 equals 15,000. Neither the 50,000 nor the 15,000, however, should be considered in an engineering economic analysis because it will not affect the future cost and revenue. So except for the manner in which the 15,000 may affect income taxes. So uh, it is included in the income taxes because when a company pays its taxes, then all the assets will be evaluated, which will be discussed in the following chapter or chapter 9. Next, opportunity cost. So 4.5, opportunity cost. An opportunity cost is incurred because of the use of limited resources, such that the opportunity to use those resources to monetary advantage is an alternative use is foregone. Thus, it is the cost of best rejected or foregone opportunity and is often hidden or implied. Okay, so these are the costs that uh, we do not decide that arise from the opportunities that we do not decide to grab, okay, or to use. Okay, when we decide not to use a resource, there is an opportunity cost there. Okay, so for example 2-3, opportunity cost in replacement analysis. So the concept of opportunity cost is often encountered in analyzing the replacement of a piece of equipment or other capital asset. Let us reconsider the past example in 2-2, in which your firm considered the replacement of an existing piece of equipment that originally cost $50,000. So it's presently shown on the company records with a value of $20,000 but has a present market value of only $5,000. For purposes of an engineering economic analysis of whether to replace the equipment, the present investment in the equipment should be considered as 5,000 because by keeping the equipment, the firm is giving up the opportunity to obtain 5,000 from its disposal. So that's it's the opportunity cost. Okay, so it is the opportunity cost. It results from the decision of the company. Thus, the 5,000 immediate selling price is really the investment cost of not replacing the equipment and is based on the opportunity cost concept. Okay, so next, let's go to 4.6, life cycle cost. In engineering practice, the term life cycle cost refers to a summation of all the costs related to a product. So we will be summarizing them, okay, into a summation. So structure, system, or service during its lifespan. So the life cycle is illustrated in the figure 2-1. So we have a figure here. Okay, first let us analyze it. So identification of the economic need or want, the requirement. Okay, so this is a requirement. So it ends with the entire retirement and disposal activities. Why? Because an economic need or want arises from retirement and disposal activities. It is a time horizon that must be defined in the context of a specific situation. So this is time bound. Okay, whether it is a highway bridge, a jet engine for commercial aircraft, or an automated flexible manufacturing cell for a company, for a factory. So whatever the subject is, it is applicable. So the end of the life cycle may be projected on a functional or an economic basis. Okay, so the life cycle of the product should be should be, uh, should be characterized or projected on economic basis. For example, the amount of time that a structure or piece of equipment is able to perform economically may be shorter than the permitted by its physical capability. Okay, because sometimes the manufacturer tells the buyer uh, that an equipment can function longer, while even though in actual run the equipment cannot function longer. It function shorter. Okay, its lifespan is shorter than what it is expected to be. Okay, so changes in the design efficiency of a boiler illustrate this situation. For example, a boiler did have you seen a boiler? So a boiler is a machine that uh, provides steam. Okay, so steam is used to cook something. Okay, to cook the product, because steam has a very high temperature. So the old boiler may be able to produce the steam required, but not economically enough for the intended use. So I have experienced this scenario in my work as a supervisor in a manufacturing company of uh, feeds of poultry. Okay, so uh, there are two boilers in the company. Okay, so one is new and the other is old. Okay, so the old one uh, produce steam. Okay, still produce steam, but it is not economically as the new one. Okay, so the life cycle may be divided into two general time periods. First, the acquisition phase and the operation phase. Okay, so that's the life cycle. Next, the acquisition phase. What is it? Begins with an analysis of the economic need or want. Okay, so the analysis necessary to make explicit the requirement for the product, structure, system, or service. So the needs or wants should uh, be analyzed. Okay, to make it clear. Okay, to make it clear that it should uh, it should incorporate with the requirement of the product. Okay, structure, system, or service. So then the requirement explicitly defined or clearly defined. The other activities in the acquisition phase can proceed into a logical sequence. So after clearly defining, uh, the activities will now proceed to a logical sequence. So the conceptual design activities translates the defined technical and operational requirements into a preferred preliminary design. So that is the transition, okay, from defining the requirement into to a preferred preliminary design. So included in these activities are development of the feasible alternatives and engineering economic analysis to assist in the selection of the prepared preliminary design. Of course, alternatives is present here. So also advanced development and prototype testing activities to support the preliminary design work occur during this period. So this advanced development and prototype testing is to test the alternatives. Okay, next, so this is the illustration of the phases of life cycle and the relative cost. Okay, so the first phase is the needs assessment, definition of requirements. So it incorporate with the cost of cumulative committed life cycle cost. Okay, and for the conceptual, it is aligned with potential for life cycle cost saving. Okay, because when we have to design a product or system, it should have the potential for life cost saving. That's why uh, there are cost efficient systems nowadays, like the fuel efficient system of vehicles. Okay, so it is potential for life cost saving. And lastly, to the retirement and disposal, it should and operation or customer use, it should include cumulative life cycle cost. Okay, because the cost is not on does not uh, the cost does not ends when you sell the product when you sold the product to the customer, because the services after the selling of the product, like the warranty, okay, it is still a cost. So further explanation of the figure, the next group of activities in the acquisition phase involves detailed design and planning for production or construction. Okay, so it is in 1, 2, 3, 4, fourth place. Okay, or fourth column. So this step is followed by the activities necessary to prepare, acquire, and make ready for operation the facilities and other resources needed. Okay, because it is the next step, so it is in preparation of that. So again, engineering economy studies are an essential part of the design process to analyze and compare alternatives and to assist in determining the final detailed design. So all of them, all the processes uh, assist, okay, or contributes to the final detailed design. Next is the operation phase, the production, delivery, or construction of the end items or service, and their operation or customer can occur. Okay, in the operations phase, it is not only the execution of the processes to manufacture or to produce a product or to execute a service, but it also includes the delivery, okay? So the distribution of those products and services to the customer. So this phase ends with retirement from active operation or use and often disposal of the physical assets involved. And of course, this service will be ended, okay, in what we call as retirement. And the priorities for engineering economy studies during the operation phase are, so here are the priorities: achieving efficient and effective support to operations. Okay, so those supports should be balanced out throughout the operation, because unnecessary support means unnecessary cost or excess cost. So next, determining whether and when replacement of assets should occur. So this is very, very important, because if you replace an asset that is functioning well, or the company can use it still, then it is a cost, okay, associated with it. So determining it is crucial. Next, projecting the timing of retirement and disposal activities. So we have to project it in relation to the operation time. Okay, so uh, this falls in the scheduling of the operation time. Okay, because we have to anticipate the retirement and disposal activities when we are scheduling. Okay, so next, the cumulative committed life cycle cost curve increases rapidly during the acquisition phase. So this increased by the acquisition phase. Okay, this cost is increased in the acquisition phase. Why? So in general, approximately 80% of the life cycle costs are locked in at the end of this phase by the decisions made during requirements analysis and preliminary and detailed design. In contrast, as reflected by the cumulative life cycle cost curve, and about 20% of the actual cost occur during the acquisition phase, with about 80% being incurred during the operations phase. So why is this? This is because when using the equipment in the operation phase, the equipment depreciates. Okay, so it incur cost. Okay, so as the equipment or material depreciates, then it is a cost to the company during the operation phase. Okay, because the company is using it. So while using it, it will have its wear and tear. That's why its value will go down in the form of depreciation. Okay, so next, thus one purpose of life cycle concept is to make explicit the interrelated effects of cost over the total lifespan for a product. So that's one purpose of life cycle concept, to make clear the relationship, okay, or the interrelated effects of cost over the lifespan of a product. So an objective of the design process is to minimize the life cycle cost. Okay, so we have to minimize it while meeting other performance requirements by making the right trade-offs between prospective costs during the acquisition phase and those during the operation phase. So that's the objective. We have to make right trade-offs or decisions. Next, basic life cycle cost categories. So first, investment cost. So this is a life cycle cost. Why? Because this is the capital required for most of the activities in the acquisition phase. So in simple cases such as acquiring specific equipment, an investment cost may be incurred as a single expenditure. On a large, complex construction project, however, a series of expenditures over an extended period could be incurred. This cost is also called as capital investment. Okay, so investment cost differs from industries to industries. Okay, because there are industries that only starts in the acquisition phase. Once the company acquire the raw materials, so that is the investment cost. The raw materials and the machine and equipments to be used, that is the investment cost. But in some types of industries, like the one mentioned here, which is a construction project, so all the requirements and needs cannot be acquired at once. Okay, so it is in the process, throughout the process. Okay, so next, operation and maintenance cost, or OEM, includes many of the recurring annual expenses items associated with the operation phase of the life cycle. So this is included in the life cycle cost. Why? Because all throughout the operation, maintenance is present. Okay? So the direct and the indirect costs of operation associated with the five primary resource areas, the people, machines, materials, energy, and information, are a major part of the cost in this category because all those said resources have their operation and maintenance costs. For the people, they should uh, get their allowances, okay, and their benefits. The machines, okay, they should get their uh, maintenance activities. So it's a labor cost. And if there is a part to change, it is also a maintenance cost for the materials. And of course, for the energy, if the energy lacks, so additional energy source, so it's a maintenance. And information, of course, for the operation. So every data nowadays cost, okay, even if it's just a data. That's why there is called a research. Okay, so research incur cost. So next, disposal cost. It is also included in the life cycle cost because they are the non-recurring cost of shutting down the operation and the retirement and disposal of assets at the end of the life cycle. Because this cost can be found in the end of the life cycle. Okay, so normally costs associated with personal materials, transportation, and on-time special activities can be expected. Okay, so they can be expected because in planning we have to anticipate them. So this cost will be offset in some instances by receipts from the sale of assets with remaining market value. So meaning the company can offset or to get back their money through the selling of assets that are not uh, that the company will not be using. Okay, so a classic example of disposal cost is the associated with cleaning on a site where a chemical processing plant had been located. Okay, because after the operation of a chemical processing plant, okay, all of these equipments will be sold. Okay, so that will offset the disposal cost. But of course, the services of selling it incurs the disposal cost. Okay,